So given the force, so what do you want to call the force, the subscripts? What subscripts do you want to give this force? Jill, taking a look at this force, what do you want to call it? Capital F, what would the subscripts be? A to B. And we're given that it's 735 newtons. And what we have to find is the moment about point C. So how do we designate that, Hallie? Moment about point C, capital M.
Well, we need to find force first.
Right, I'm sorry, but just I wasn't asking a clear question, but the variable for the moment, I'm going to call it M sub C because it's about point C. So let's take a look up here. So we're trying to find the moment about point C, and the force goes from A to B. So Paul, what is my R vector going to go from and to?
The R vector, about point,
So the R vector has two subscripts.
right?
It goes from what point?
From point C.
Right? From the tail of the, from the point I want to find the moment about,
Right.
point
C
of moment,
of moment here.
and where is it going to?
Well, it looks like it's going to be going to B. So.
We're always
Force is being applied to B, or is it?
forces from A to, take a look up here, you guys.
It looks like it's C.
C to C and A to A.
Okay. C to A.
So it's going from the point I'm finding the moment about to the tail of the force. So you look at this and you see CC and then you see AA. And what Ellie said is correct. You have to find the components of the force vector. So how many minutes can you find the force vector in? A minute and a half, you think you can do it? Let's see. See how fast you can do it. 735. Do the three-step process. And you have all the distances. You guys probably can't even see that. It's so light. Hey Kyle,
Mm-hmm.
would you go on meet 10 and see if you can get a black, or a couple of black ones? White ones, right here. Okay, who got it already? Who got the numbers? All right, could you check me? Is this right? 5450?
Yeah, well, I got the same final answer.
Okay, 400, did you get a 0 in the decimal places?
I got a 399.7.
Did somebody else get 399.7?
But I might have rounded my numbers, so that's probably right. I think I
What did
rounded
you
it.
get, Kyle?
If you want.
Did anybody get 400.3?
Yeah,
That's probably
Or-
right.
we're going to keeping us everything.
400.2. What'd you get for this 500? What'd you get? 0.7? Peter, what'd you get?
500.3,
Wow.
close enough. Let's keep it like 9 digits.
So let's just keep since you guys are having things across the board, I'm just gonna keep it the way I had it. Ooh, that's nice. Okay, so let's do our checks. 400 squared plus 500 squared plus 360 squared under the radical should be equal to 735, and it does, okay. And then I'm gonna do my positive and negative visual check. And I asked you to do this on the exam, and some people forgot to do this. The x and the y should be positive, and yes, they are going to positive x, positive y, and z is negative, so that's okay as well. Okay. Okay, next, we have to find the r vector, right? The r vector going from C to A. David?
So the question of why we're analyzing point A instead of point B for the force. Because I feel like if you're pushing point B, it's gonna rotate from there, not from point A.
Okay, so let's talk about it mathematically for a minute. We're solving for our moment, and it's r cross f, right? So what does m represent? What is my moment? What does the vector m represent in comparison to r and f?
Like sort of couple of two.
Right, Santiago, you said it last time too, that the moment vector is perpendicular to both these vectors. Whether I go RCA or RCB, if I cross it with AB, I'm going to get the same exact value. And I'll give it to you something on Tuesday that shows that you could actually have done it 2 ways. But for me, I always want to be consistent, so I always do it to the tail of the force. Because typically, you don't know where this is. They don't give you information maybe on the second point. So the tail is always the one that we're coming from, and we usually know the information on. Okay? Okay, so RCA. So Peter, we're up to you. So let's draw this. I'm going from C to A. So this is my R vector, RCA. So going from C to A, how much am I going in the X?
The x, 100,
Yes, positive or negative?
positive.
Take a look up here. Where's the positive X
Oh,
value?
sorry, yeah, negative.
It's, the positive X value is going this way, you're going from C backwards, so it's negative 100, I. Okay, how about the Y, Peter, keep going?
The y, positive, yeah, positive 250.
Great,
And
And?
then z is positive 180.
what? I didn't hear what you
Yeah,
said.
positive 180.
Okay, is that right? I'm not looking, anybody else got that?
Yeah.
Okay, and what's the units on the R vector? Millimeters. Does it make sense that it's a unit of length? The R vector is a unit of length, does that make sense? Yes. So Karen, now that I have these two vectors, the R vector and the F vector, how vectorially do I solve for this moment?
You're gonna do the cross product and the matrices.
Right, the matrices. So what goes along the top row of the matrices?
IJK.
I, J, K. And then what goes along the second row?
Second row would be the FAB.
Try it again.
Oh.
It's R cross F. So
R
it's a good
is-
way for us to remember it. R goes first. So this has got to be R, CAX, right? So Eric, G, tell me what numbers I should put in here.
Negative 100,
Okay?
250,
Yeah?
180.
180. Mark, what's the third row going to be?
Should be the 4,
Okay, and what is that?
400,
Yeah?
500, and negative 360.
Right. And then whatever way you do it, you're probably going to wind up doing it on a calculator. You're going to get a value of okay, it looks like you're going to have to do, oh, I got it. 180I negative plus 36J minus 150K, and the units are, I think it might be a Newton meter. Could you guys put this number into your calculator? I think you're gonna get 180,000. Did anyone get the number yet? I'm pretty sure it comes out to be Newton meter, because I think I dropped the 3 zeros.
Yeah.
Yeah? Okay, everybody's taking a top. This goes with this. Pass that down. Pass this down. Pass this down. This goes with this. This goes with this. This goes. Two, ready?
Hey Joanne,
Yes.
do you know how to do the cross product with a calculator? Is there a way to do that?
Yes, but you gotta learn it on your own.
Is it a workshop?
It was a workshop.
Okay.
What I had to do for the cross product was set up like 3 2D matrices and then